Hello everyone, in this video we'll be discussing some past years of MME 1, which is the part of MME 1 of Delhi University. So we'll discuss these questions. First, question 1, part A. First, you can look at the question. You are supposed to find all the values of x satisfying this equation. This equation. Okay, I will just copy this. Mod x minus 2 into x plus 5, this should be less than 0. So we cannot have the case where this is positive and this is positive, because that would lead to greater than 0. And we cannot have the case where both of them are negative. That would also lead to greater than 0. So we'll remove these cases and we'll focus on two cases. Case 1, where the first element is positive and the second element is negative. And case 2, where the first element is negative and the second element is positive. So the final answer would be a union of both of them. Now coming to case 1, mod x minus 2 is greater than 0 we have, and we have discussing case 1, and x plus 5 should be less than 0. So this gives us x should be less than minus 5. So the range is minus infinity to minus 5. According to this, mod x should be greater than 2. Mod x is greater than 2 when x lies in the range minus infinity to minus 2 union 2 to infinity. And now since we want both these cases, we'll have this intersection minus infinity to minus 5. So we'll get the value minus infinity to minus 5. X would lie in this range. This is for case 1. Now case 2. When mod x minus 2 should be less than 0 and x plus 5 should be greater than 0. And so this means x should be greater than minus 5. This means mod x should be less than 2, which happens when x belongs to the range minus 2 to 2. And this is x belongs to the range greater than minus 5, so minus 5 to infinity. If we take a intersection of this, the final range would be minus 2 to 2. And these are exclusive. So we have got this thing and union this thing. So the final value of x for which all these equations are satisfied is x belongs to the interval minus infinity to minus 5 union minus 2 to 2. You can put these values on the number line and look at it by yourself as well. So minus 2, here we have 0, 2. So if we take suppose the value of 0, this would be minus 2 into 5, which is less than 0, right? So this portion is included. Similarly, you can put the value by yourself. You'll see this portion is also. So putting the values helps in verification of the answer. I hope the first part is clear. Now moving to the second part. If A and B are two sets containing 4 and 7 elements, now we are supposed to find what is the maximum and minimum number of elements in A union B. Okay, A has, second part, A has 4 elements. B has 7 elements. It is given to us. So now with the help of the Venn diagram also, you can see the maximum number of elements would be possible if A and B don't have anything in common, which is when A intersection B is 0. So in this case, A would have 4, B would have 7. So the maximum elements possible would be 11 in this case. Now if we want to find about the minimum elements, when A would be a subset of B, then only they would have the minimum elements, and in this case the minimum elements would be 7. This was quite straightforward, so I guess every one of you got it. Okay, so we are done with question 1 A part and B part. Now question 1 A part, first and second. Now looking at necessary and sufficient conditions. Okay, so if looking at part 1, if A is a sufficient condition for B, then not B is dash condition for not A. So we know if A is a sufficient condition for B, which means B is a necessary condition for A, which further means not B is a sufficient condition for not A. So it is a sufficient. Okay, now for a rectangle to be considered a square, having 4 sides is necessary and of equal length is sufficient. So if you have a rectangle, it is necessary to have 4 sides if you want to have a rectangle. But if you have the condition that it is of equal length as well, which means it is a square. So it is both necessary and sufficient. Now look at the third part. This means x greater than 0 is dash for x into x plus 4 to be greater than 0. But this is sufficient only because in other case as well, in the case where x takes value, so suppose both of them are less than 0, x is less than 0, x plus 4 is less than 0. This happens when x is less than minus 4. So when for any value of x less than minus 4, you will get x into x plus 4 to be greater than 0. So suppose x is minus 5, you can see this would be minus, this thing would be minus 5 into minus 5 plus 4. This is minus 5 into minus 1, which is greater than 0. So this is sufficient, but this is not necessary, because we would have different combinations ranging from minus infinity to minus 4 for which this equation is also satisfied. Now coming to part 4, for two sets x and y, x union y equals to x. So this would mean if we are talking somewhere here, x union y is x, so y should be a subset of x. So this is both necessary and sufficient, or else this condition won't be true. Necessary and sufficient. I hope this was clear. Now solving question 6. Okay, you can have a look at this for a minute. So in this question, the total cost function is given to us, which is a function of quantity, and the demand curve is given to us. Cost function is this, demand curve is this. We are supposed to find equilibrium price and quantity. Okay. Solving the answer 6, the cost function was half x square and demand function was 12 minus p. Now the profit for a monopolist is total revenue minus total cost. We can find the inverse demand function, it would be 12 minus x. Total revenue is nothing but price into quantity. Quantity here we are denoting by x. So this becomes 12 minus x into x, which is 12x minus x square. The total cost is half x square. So the profit function becomes, profit of monopolist as a function of quantity becomes 12x minus x square minus half x square. Okay, now the first order conditions would give you the optimum point. In this case, this is 12x minus, okay, this is 3 by 2 x square. So 3 by 2 into 2x should be 0. Okay, so this would be 12. Okay, I'll do this again. So the first order condition would be 12 minus 3x should be 0. This gives x equals to 4. We need to check the second order condition as well, and this is coming out to be minus 3, which is less than 0. So this suggests that this will give us a maximum value. Now if we know the quantity, we can find the price charged by the monopolist as well, which would be 12 minus xm. Since xm is 4, the price of monopolist would be 8. So we are done with the part 1, where we were supposed to find the equilibrium output and price. Now coming back to part 2, what would be the equilibrium price and quantity if the monopolist is forced to take the price as given under perfect competition? And then we need to compare the profits of the monopoly and the perfect competition. So in case of perfect competition, we know one thing: the profit maximizing output is the so the profit maximizing condition is price equals to MC. Here marginal cost is differentiation of total cost or differentiation of total variable cost, which gives the same thing only, because del total fixed cost by del Q is 0, because fixed cost doesn't change with change in output, right? Now the condition P equals to MC. Marginal cost in this case would be derivative of half x square dx. So we'll get x as the marginal cost. Price was 12 minus x. So at equilibrium, 12 minus x implies 12 minus x should be equals to x, which means 2x should be equals to 12. X is 6. X in case of perfect competition is 6. Similarly, we can find the price for it. Price would become 6 only. So now comparing the profits of the monopolist and the perfect in the case of perfect competition. So in case of monopolist, the profit level is total revenue minus total cost. So okay, I'll draw a diagram first, draw a table. This is for monopolist and this is for in case of perfect competition. Price, quantity, and then profit. We have already seen price in the case of perfect competition is coming out to be 6. In case of monopoly, the price is coming out to be 4. Sorry, the price is 8 in case of monopoly. The quantity here is 4. The quantity in this case is 6. As expected, it is expected that the output produced by perfect competition would be more, as we can see in this case. Okay, now looking at the profit level. So the total revenue is for the monopolist. Suppose you're finding about for the monopolist 8 into 4, which is 32, minus we need to subtract the cost. The cost is half x square. So x is 4 in this case. This is 32 minus 16 by 2, which is 8, so 24. The total profit for the monopolist is 24. Now looking at the profit of perfect competition, we know the total revenue in case of perfect competition is 6 into 6 minus the cost, which is half into 6 square. So 36 minus 18, which fetches us a profit of 18 only. As expected, the profit of the monopolist is greater than the profit in case of perfect competition. Now looking at the third part. The third part wants us to know, so if the government wants to make the monopolist act as a perfectly competitive firm, so the government is imposing a specific tax of T per unit. We need to find the equilibrium output T and show that it is actually negative. And what does this imply? I'll explain it in the video only. What does that mean? Now the question is, the government is imposing a specific tax. Okay, I'll explain it. Okay, the third part states that government is imposing a specific tax. I hope you know the difference between specific tax, ad valorem tax and lump sum tax of T per unit. They're imposing a tax on the monopolist so that he acts as a perfectly competitive firm. So now the total revenue for the monopolist would remain same, which is P into X, which is 12 minus X into X, which gives you the value 12X minus X square. But now the total cost becomes half into X square, this was the original cost, plus T times X. Because this is the per unit additional tax they are supposed to pay. Now the profit of the monopolist in this case would become 12x minus x square minus half x square minus tx. The first order condition gives us the value 12 minus 2x minus x minus t equals to 0. We can check for the second order condition as well. Is coming out to be minus 3, so which is less than 0, which means this value would give you the optimum value. Okay, now we have got this 12 minus 3x minus t equals to 0. Now if we want the monopolist to act as a perfectly competitive firm, we have already seen that the perfectly competitive firm is producing output level 6. So the tax should be in such a manner that this output is of a perfectly competitive form. So we can substitute the value which we have already gotten, which was 6. So 12 minus 3 into 6 equals to t. Now this becomes 12 minus 18 equals to t. Therefore t equals to minus 6, which means this is not a tax but a subsidy. So the government would actually give a subsidy to the monopolist so that they produce more, and then only it can act like a perfectly competitive firm. So if the government wants the monopolist to increase the output level, they will give subsidies instead of taxing. I hope this was clear.